Imagine that we have a block, we push it, and we have infinitely precise instruments to measure the mass of the block and its instantaneous acceleration and position as it moves. Newton discovered that there is a mathematical relationship between the mass of the object, its instantaneous acceleration, and the force or push that is being applied on it. F equals ma. This force can vary or be constant, which implies, because of the equation, that the acceleration in which the object moves can also vary or be constant. Imagine that, using precise measurements we have collected, we design a function that relates the force being applied on the object to its position. Then, we graph this equation, labeling the magnitude of the force being applied in the y-axis and the object's position in the x-axis. When you take the area between the x-axis and the graph of the function between any two points in the x-axis or instantaneous positions of the object, you're essentially utilizing a calculus technique called integration, which allows us to calculate the change of a function using geometric and algebraic methods. To transform Newton's expression to 1/2 times the mass of the object times the final velocity of the object squared minus 1/2 times the mass of the object times the initial velocity of the object squared. This last equation is defined as the work applied on the object, and physicists define the quantity 1/2 times the mass of the object times its instantaneous velocity at any moment as the kinetic energy of the object at a certain point. So, expressing this quantity as k, we can clearly see that work is equal to the change in kinetic energy of the object. The principle of conservation of energy, which has no exceptions, states that no new energy is created, nor any existing energy destroyed. Therefore, to account for any change in the kinetic energy of an object or situation being analyzed, physicists define the change in potential energy as the opposite of the work equation, or the change in kinetic energy. This definition highlights the principle of conservation of energy, and is very useful for physicists that want to determine various characteristics about a physical system or object, while only having limited information about it, such as mass or velocity at specific points in time. Physics helps us explain how the world around us works. This video has been a mathematical introduction to the concepts of energy and work, which have applications all throughout the universe. Thank you.